Hi guys, how you going? I just want to go through an interesting model I saw at our latest training days, and it's a really good way of actually helping students who struggle with getting into a question. So I just want to go through the techniques and show you a couple of examples of how that works, and hopefully I'll get them right. So we'll see how we go. So obviously looking at this sort of question, so Sam has a total of $100. Sam and I have a total of $100. Sam has $20 more than me. How much money does Sam have? Now, if I ask that question to kids, a lot of them will get that right. It's a pretty simple question, but just show you a technique of using the model method, right, to actually represent that. So if I look at how much money I've got, Sam's got the same amount of money as me, but Sam's also got $20 more. So if we think about the logic, if we take away the $20, obviously these two boxes have to add up to $80. So if I look at me and Sam, so therefore we're going to have $80, divide that by 2, add the $20 onto that, so that means Sam's going to have $60 and I'm going to have $40. Alright, so I think it's a really nice way of representing the question in a graphical way. Obviously the ultimate aim is to get kids working using algebra and using symbols rather than that. So, but I mean, I think this is quite a good transition for students. So this question here, the farmer has 5 times as many chickens as ducks. There are 84 more chickens than ducks. How many ducks does the farmer have? Well, again, we can represent that as by using our model. So we've got one box there for a duck. We've got 5 as many chickens as ducks, so there'll be 5 boxes there. And we know that there are 84 more chickens than ducks, so we could represent that distance there as 84. And so therefore what we do know is that 4 of these units is actually equal to 84. So 4 of these little units is 84, so divide that by 4, get 21. And we know that one of these units is 21, so therefore that is equal to the number of ducks. So, it's another, again, a fairly simple way of showing your students how that they can use these models to get into the question. Alright, so going to the next one. So here's a book problem. So Jane reads a fifth of the book on a Monday, a quarter of the remaining book on the Tuesday. She's left with 60 pages of the book to complete. How many pages does she have in the book? So on the Monday, if we represent 1/5 of the book by a red square there, on the Tuesday she reads another quarter of that, what's left over, so that would be that amount, and we know that the rest of the book has to account for 60 pages. So you can actually do that visually. So if you think about that, we know that 3/5 of the book is in fact equal to 60 pages. Do some algebra there, you can work out the book actually has 100 pages. Alright, so get the idea? I think it's a really nice way of representing that idea. Alright, so next question, stickers. Okay, Sally and Jack have 990 stickers together. Sally has 20 more than Jack. How many more stickers does Sally have than Jack? Well, when we're looking at this over here, we can say that Sally's got 100% of her stickers and Jack's got 100% of his stickers, but we know that Sally's got an extra 20% of the stickers. Alright, so all up, they can have 220% of the stickers. 220% has to equal the 990 stickers. So if we do that, the calculations there, we can work out that 1% is actually equal to 9 over 2. So therefore 20% is equal to 20 times that, which works out to be 90. So Sally will have 90 more stickers than Jack. Alright, so again a ratio problem. So this one's an interesting one. Shane, the ratio of Shane's money to Mary's is 4:1. After Shane has spent $29, Shane has $2 less than Mary. How much money did Shane have at first? Well, we can represent Shane as 4 units, Mary as 1 unit. We can take away the $29. Right, so we take away the $29 and we know that that line there is equal to $2. So therefore we know this distance here has to be equal to $27. So now what we know is $27 is equal to 3 units. So every one of these units is equal to $9. So therefore, if we look at how much money Shane had, he had 4 units to start with, which means he has $36. So again, I think graphically seeing this sort of question really makes it accessible for our students, and I think it's a really good way of teaching them to get into that sort of question. Right, looking at this one over here, so we've got some students or kids playing computer games. Right, so information that Aaron scored 10 more than Mark scored 8 more than Peter, and they had 62 points all up. So what we could do is represent all the points that they got by that amount, and we know that Mark's got 8 more than Peter, and we know that Aaron's got 8 more than, or 10 more than Mark. So we know that all of these things here have to add up to 62. So 3p plus 8 plus 8 plus 10 is equal to 62. Take the numbers away over there, so that's 36. So Peter must have 12. Again, I think it's a really nice, simple way of representing that information. Alright, farm animals. Okay, we've got 1,000 animals over here, or 1,200 animals. 1/3 of the animals are sheep. The rest are other farm animals. 5% of the other animals are chickens. How many chickens are there in the farm? So we could represent that there as 1,200, and I've divided into 3 because we were using 1/3 over here. So 1/3 of the animals are in fact sheep, so that's 400, which means the other animals must be 2/3 or 800, and we know that 5% of those in fact are going to be chickens. So 5% of 800 works out to be 40, so we must have 40 chickens. The last one we'll just go through here is, or actually not the last one, the second last one, is looking at the volume of a box. So if we're giving this information here, again it's about representing the diagrams in terms of an equatable size, divisions. So if we're looking at box A, I've looked at this and I saw 21 there, so I've got 21 squares here on my particular box A. So that's the size of box A, because box A is the biggest one of all the boxes. So box B is in fact 1/3 of box A, or box A is in fact 3 times bigger than box B. So that's 1/3 of that. Alright, so that's my representation of box B. We know that box C is 12 times the volume of box C. So box C would be one of these little divisions here. So obviously 1/3 and then 1/4 of that is 1/12, and then box D is in fact 21 times the volume of box D. So then again we divide that into 7, so that's going to be our box D. Now comparing our B and our D, we can see that obviously box B is going to be 7 times bigger than box D. So that's what we would then write. Or if we were looking at box C, we could say that box C, or box B, is actually 4 times bigger than box C. Alright, so you can equate and play around with those things there, but it's about getting these connections, about spacing there for that example. Now this is I think the last one. So the distance from X to Y is 3 times the distance from Y to Z. So if we label these things X to Y and Y to Z, alright, so what we've got here, the distance from X to Z we know is 160 meters. Okay, so this is the YZ distance, that's 3 times X to Y. So what we know there is that 2/3 of a unit is in fact equal to 160, so therefore 1 unit must be equal to 240, and so therefore the distance from Y to Z has got to be 80 meters. Alright, so I think these are really good simple examples. Using this model method I think helps a lot of our students, certainly will help a lot of our students get into having a go at these questions. I mean ultimately we want to take them to do it algebraically, and I don't see there'd be a problem doing both algebraically and also doing the geometric way using this model method. So have a go at this, see if you can have a try in your class and see how your kids like it, and give me some feedback. See ya.